So the last thing was discussed was the flip-flops and the 4 types of flip-flops. If you remember, we said that we have 4 types of flip-flops. We have the SR flip-flop, which suffers from certain case. This is the problem of the SR flip-flop. So if you get a question like, what's the main problem with the SR flip-flop, then you have to talk about this status or this case, which is not allowed or undetermined or whatever the name is. This is the main issue with SR flip-flop. Then we converted this SR flip-flop to D flip-flop by connecting the SR together, connected through or via an inverter. So there are only 2 cases, either 0, 1 or 1, 0. This is the second. This is the first flip-flop. This is the second flip-flop. Then we got feedback from SR, okay, to the input, from the output to the input. Then we got something called JK flip-flop, and this is called the universal flip-flop. Why is it a universal? It's a universal because it can be used to implement all the other kind of flip-flops. Now, if I got this JK flip-flop, JK, okay, and connect them together, and with one output, then I'll be having T flip-flop. Of course, in JK flip-flop, the main advantage that it works exactly like SR till here, but the undetermined case has been utilized to be toggle. That means the output will be the opposite of the input. Then this is the other type, which is the T flip-flop. So these are the main 4 kinds of flip-flops. Of course, everyone can be used. This can be used for memory, okay, and this can be used for frequency division and counter. Okay. Now let's see how to use them. Before that, we need to discuss the characteristics equations. The characteristics equation, how to describe the next state, a description of the next state table of flip-flop. So it's very much similar to truth table, but it's different. Constructing from the K map, okay, for Qn plus 1, and we said Qn plus 1 is the next state of Qn, okay, in terms of the present state and input. So let's see how to derive the characteristics table. Characteristic table, the table that we've made so far are called characteristics table. This is the characteristics table. So if I give you a question, write or draw or give the characteristics table of T flip-flop, then you have to write this. Okay, when T is 0, then Q plus, of course, Q plus means the next state will be Q of T. When it's 1, then Q of T prime. This is the characteristics table of D flip-flop. When D is 0, then the output is 0, then the next state will be 0 and 1. Here it depends on the input only, okay, but it keeps the input, it latches or keeps the input for even after you remove the input, it will keep the same value. Here is the characteristics table for JK flip-flop and SR flip-flop. This is the characteristics table of SR flip-flop. Okay, we have characteristics table. Here we are talking about tables, if you didn't notice, and we have characteristics equation. We need to derive the characteristics equation of the characteristics table. We can also write characteristics equation where the next state is defined in terms of the current state and the input. Of course, I don't know if we have it. Then we don't have it. I'll add another. Yeah, it's here. Okay, let's see if JK flip-flop also we have it. No. Let's derive the characteristic table for the flip-flops and see how to derive them. Okay, Then I'll continue here. All right, let's start with D. Now, no need to have, you can put it like this, the truth table, D and Q plus. Of course, since it's equal to Q plus now, 0, 0, 0, 1, 1, 0, and 1, 1. If D is 0, then the output is 0. If D is 0 here, the output is 0 also. When D is 1, the output is 1. And when D is 1, regardless of the output, then the D is equal to 1. So this is the characteristics or the truth table for the D flip-flop. Next, I can draw the K map D and Q. Of course, two cases only. So I have 1, 0, 1, 0, 1. I have 1 at 1, 0, 1, 0, 1, and 1 here. Then next step, I take this group. Then this group is equal to D. Then Q plus is equal to D. Of course, Q plus means Q of T plus 1 equals D. So this is the characteristics equation and how to derive it from this. Now T flip-flop, I'll derive it for you. All right. So for T flip-flop, always is toggle. So I'll draw the truth table also. I have T and Q, Q plus 0, 0, 0, 1, 1, 0, and 1, 1. Now, remember when T is equal to 0, Q plus is equal to Q, then this is 0, 1. When T is equal to 1, then Q plus equal Q prime. So 0 will become 1 and 1 will become 0. Then the K map again, T and Q, 0, 1. Zero, 1, and 0, 1. All right. Then I have 1 at 0, 1, 0, 1. I have 1. Right. 0, 1. I have 1. And I have another 1 at 1, 0. Of course, you cannot take the group like this. So you'll take the groups separated. This will give me Q prime dot T, and this one gives me Q T prime. So F is equal, or Q plus is equal Q T prime plus Q prime T. If you go and check, you will find this is the equation that we are talking about, which is exclusive OR. All right. Characteristic equation of SR flip-flop. SR flip-flop, I write it here. This is T flip-flop. Let's talk about SR. In SR, what I have S, R, and Q plus. Right. Let's go 0. 0, 0, 1, 1, 0, 0, 1, 1, and here I have 0, 1, 0, 1, 0, 1, and 0, 1. Now Q plus. In SR 0, 0, it's no change states. Okay, this is no change. Okay, if R is 1, then the output will be 0 always, right? If S is 1, the output is 1 always. And here, remember the don't care cases. Okay, so I'll draw the K map SRQ. Then I have 0, 0, 0, 1, 1, 1, and 1, 0, 0, 1. Okay, so the 0, 0, I have 1 only when Q is equal to 1, then 0, 0, 1. All right. Next, 0, 1. I don't have anything. I have another one at 1, 0, 0, 1, 0, 0. Okay. And I have another one at 1, 0, 1. This is another 1. Is it enough? No. Still, I have the don't care here. At 1, 1, 0, 1, 1, 0, I have don't care. And at 1, 1, 1, I have don't care status. Then the groups will be, if you remember, we talked about the don't care. Then I'll consider these don't care as ones. Okay. Would you give me 1 second, please? الله يكتب خيرات يا محمد الله يحفظك يا أستاذ. ايش هو؟ اوكي اوكي غيره عادي وغيره بالعربي وارسله. ما هو انا مترجمين بالعربي بالتايتل. في الرسالة. اوكي. تمام. ايوه. خلاص تمام. اذا عدل. خلاص عدل لما تعتمده. ايوه. كيف مكتوبة؟ قصدك انه فيرتيكال مكتوبة. ما مشكلة بنعدلها. بعد في شيء انت شوف طلع عليه واي تعديلات عندك ارسل لي هون بدل. لا ارسلها للشيخ حتى تجهزهم على اوراق رسمية. يعني ارسلها لي وش. Sorry guys. Okay, where's my stylus? All right. So talking of which, forget about the phone. I have here the don't care cases. I've considered them as ones. All right. I told you, if you remember, I told you whenever it's useful to consider it as one, use it as one. Wherever you feel it's useful to use it as zero, use it as zero. So I consider it here as one. So this is the first group. The second group will be here. This is the second group. Okay, so from the first group, I will get one is constant here, which is S. Okay, so it's only S in this case, correct? 1, 1, 1, 0. Okay, S, and the other group gives me Q R prime. So it's supposed to be S plus Q R prime. Yeah, this is the result. And that's why they use this is don't care and this is another don't care. Okay, JK flip-flop also in JK flip-flop. Let's derive the JK flip-flop characteristics equation. J, K, and Q 0, 0, 0, 1, 2, 3, 4, then 1, 2, 3, 4, 2, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1. All right, this is Q plus 0, 0 is no change, so 0, 1. This is no change. JK, if you remember, I told you, remember that K is very much similar to R. then it's a reset. 1 0 is j is equal to 1, it's a set. Then 1 1, this is set. Here is toggle. So 0 will become 1 and 1 will become 0. So the same way, I can put j, k, q, and 1, 2, 3, and 4. 1, 2, 0, 0. 1 0 0 1. Then I have one at 0 0 1 0 0 1. Okay, I have another one where at 1 0 0 1 0 0. I have another one at 1 0 1. Okay, and I have one at 1 1 0 1 1 0. I have this one. So I can take these groups. This is the first group, and this is the second group. From this, I can get q prime j, right? So j is constant here. From here, I can get q k prime. So I suppose I expect that q plus is equal j q prime plus k prime q. Let's see the where is it? We don't have it here. I think next. Yes, jq prime plus k prime q. This is the equation and how to derive it. Okay, very well. Now we have an example, an application about, remember registers. When you hear the word register, that means 100% I'm talking about D flip-flop. Of course, D flip-flop or JK or SR, because both of them can be used as D flip-flop, correct? If I use SR, then I can convert them to D flip-flop like this, D. So in all cases, the word register means a place where I can store a bit for a while. Then I'll use, or certainly I'm going to use the D flip-flop. You cannot use T flip-flop for registers. Why? Because the T flip-flop toggles or reverse the signal, invert the signal or the input. Okay, so register means D flip-flop. Counter means T flip-flop. Remember this, please. Okay, of course, T flip-flop also can be derived from JK flip-flop, because when you link the JK flip-flop together, J and K together, you will get T flip-flop. All right. Then the first register we're talking about is the basic register. Typically, we store multiple bit items. For example, 4-bit binary numbers. Register multiple flip-flops sharing clock signal. What does that mean? Sharing clock signal. That means this. They share the same clock signal, and we've taken an example and we saw how that happened. But what's the difference between this example and the previous one? Please focus with me. If I go back and yes, this one. This is called serial. Why serial? Because I have one input and one output. So if I want to enter the values to the flip-flop, then I have to move the bits from one stage to another. That's why it's serial. The other one is parallel. Remember, again, one input, one output, and the input comes from one place. So here it's parallel. Why is parallel? Because I have multiple input, 4 input and 4 output. See, there's no connection between the flip-flops. The output of this will not move to come to the next stage. It will get the input from here and get it and put it on the output. All right. So this is the register or 4-bit register. Now, sharing the same clock, this is very important. So if I put like 1 0 1 1, okay, then the first clock pulse, of course, here the change will be in the positive. Why the change in the positive? Because here I don't have bubble like we used to use. We don't have it. So the change will be in the positive. Remember, if I have bubble here or circle, that means the change will be in the negative here. But now it will be, the change will happen or take place here. So here, if I give the signal or the clock pulse, then at this place the output, whatever the value of the output, will go to the input. Sorry, will go to the output. So the output of this 1 0 1 1. After which, if I remove the clock pulse and remove the input, then the D latch will keep the output forever. And this is the basic idea of memory. I'll keep it for a long time, and this can be, of course, summarized to be like this. This is just an example. I don't want to go through it because it's sort of we'll take better examples. All right. Now binary counter. Again, here we are talking about what? About registers, right? Remember, this is a register. Okay. A register means D flip-flop. Okay. Now let's go back or let's continue. Here we are talking about counters. Counters means T flip-flop. Okay, because it toggles the signal. So I'll explain this also. See here. First of all, the change will take place where no bubbles, right? No circle. That means positive edge. So the change will take place in the positive edge. And of course, the same thing happens here. Here also positive, and here positive. Sometimes, be careful. Sometimes I may give you one positive, one negative. You have to be very careful. Next, I have one here, one, okay, input to all T flip-flops. Why I give one? Because I want the flip-flop to work in the toggle states, okay? Again, here the output will enter to the clock, right? The output will come to the clock. Remember, I'm comparing this with the previous thing. They don't share the same clock. If you go back, here you can find the clock pulse is shared by all, right? All inputs, all flip-flops, all stages. But here, they don't share the same. They don't share clock. Okay, the output of each stage will go to be a clock. Now let's see the timing diagram. This is the clock. Okay, I don't have any problem. Then since I don't have circle here, the change will be here. So from the beginning, I want you to check or to draw where the change will take place. Next, I'm sorry. If you can see here, we took the signal from Q prime. That means Q prime, it's very much similar. If I took it from Q, this is similar to T1, then I have clock. I can take it from Q and put an inverter, right? It's very much similar. So I took it from Q prime or this, both are the same. That means the change will take place where? In the negative. Okay. Let's see. Now, in the first clock pulse, the value of Q0, this is Q0, was 0, but at the positive, it will toggle to be 1, correct? At the next clock pulse, it will find that the value is 1, then it toggle it to 0. Next, continue. Here also, they'll find that the value is 0, then it toggle it to be 1, and so on. Okay, this is the first stage. The second stage here, the change will take place on the negative or the falling edge, then the value is 0 up to here, then it will be changed to be 1. Of course, here there will be no change. Why? Because we said the change is in the falling edge. So I'll continue like this. Again, 1, 0, 1, 0, etc. Now this is the Q1. Q2, the change will take place also in the negative. Why in the negative? Because I took it from Q minus, Q prime. Then the negative, but it will change with respect to this one. Okay, then it will go like this, 0, and until it reaches here, then it will become 1. No need for to avoid any confusion. The change will be here, and the change will be here also. Finally, this also taken from Q plus, and the change will be a negative, but with the clock like this. This is the clock. So every output of every stage will be clock of the next stage. Then this is the clock, and the change will take place here only. Okay. If you come and put the values 0, 0, 0, 0, then 1, this is 1, 0, 0, 0, 0, 1, 0, 1, etc. So if you put it vertical, you'll find it's a counter. It counts from 0, 0, 0, 0, then 0, 0, 0, 1, then 0, 0, 1, 0, 0, 0, 1, 1. See? Check it and you'll find like this. But be careful. Q0 is here. Okay. The most left stage is Q0 because this is what was changed. So if you want to put it as a counter, you shouldn't put it like this. You should put it like this. This is Q0, 2, and 2 will come here, and then 3 will come here. Okay, that means to make it reasonable. Okay. Finally, this register, I will give it to you as practical. The shift register, we've already explained it, correct? The same like this one that we explained. No, not here, somewhere. Yeah, this is the shift register. Shift or serial register, okay? So, serial transfer, yes, this I'll postpone for now, okay? Serial transfer. Just let me see. Else we left. Okay, serial transfer. It's very, very easy and simple, by the way. I'll show you how to do it. You have two shift registers. You have this shift register A and shift register B. You want to transfer the data here. If we assume that we have 1, 0, 1, 1. Okay. I want to copy. Remember, copy, not to move. If I want to move, then I will discard this. But I want to copy the values here into register, into shift register B. So the clock pulse, okay, shift control here. If I put the shift control into 1, okay, then I can start shifting with the clock pulses. If I want to stop shifting, then I will put it to 0. If you can see here, 0 only here will allow the shift. All right. Now in the first clock pulse here, okay, it's considered as 1. Okay. Then in the first clock pulse, the 1, this is the first one. I'll change the color. It's better. This one will come and be shifted here. So I'll start from here. So 1 will come here, but at the same time, if you can see from here, it will go back to the register. So I'll put the contents of the first register, register A and B, A and B. At the beginning, the contents was, okay, I need the longer space, a bit longer space, or larger space. So I'll put it here. I have A register and B register, and here the clock. So at the first clock, initially A was containing 1011. How about B? I don't care, whatever the values that it contains, I don't care. Now, the first clock pulse 1 will be shifted here. But at the same time, see, 1 will be shifted here, but at the same time, it will go back and inserted here. So 1 will come here, the contents 1, 0, 0, 1 don't care, and don't care, okay? And the other numbers, of course, it will come back here, the input or the content will be 1, 1, 0, 1. This is the first clock pulse. The second clock pulse, 1 will come here, everything will be shifted, then 1, 1, don't care, and at the same time, this one will come here, then it will become 1, 1, 1, 0. Third clock pulse, 0 will come here, then I'll be having 0, 1, 1, X, and here 0 also will come here, then 0, 1, 1, 1. Fourth clock pulse, 1 will come here, then I'll get 1, 0, 1, 1, and also will come to the end, to the back, and then 1, 0, 1, 1. So if you can see, after 4 clock pulses, I got both registers containing 1, 0, 1, 1. All right? So this is copy, not move. That means copy. If I want to move them, then no need to get the feedback, this feedback. If I put a switch and stopped it, then I can move the contents, not to copy the contents. Serial adder, now the same idea. You have full adder, remember the full adder? Okay, and D flip-flop this for delay. And I have shift register, okay, and I have shift register B. The first one, the first register maybe, let's if we consider that it contains 1, 0, 1, 1, and the other one contains 0, 1, 0, 1. Then, based on the clock, see this clock will control everything, okay? Serial input, of course, here's serial input, and here I have control, shift control, okay, and the clock. Regardless, so in the first clock pulse, here I put the contents of A and B, again, A, B. At the beginning, I assume that this one has 1, 0, 1, 1, and this one has 1, 1, 1, 0, 1, 0. So first clock pulse number 1. This one and this 0 will go out to the adder, correct? Then 1 plus 0, the sum will be 1, the carry will be 0. And the next clock pulse, this 0, of course, this will be blocked here, but this 0 will be moved here. This one will move to be input. Then the input of the A will be 1, 1, 0, 1. What will be the contents of B? Regardless, don't care. 1, 0, 1. Next clock pulse, this one and this one will move to the serial adder, all right? Sorry, to the full adder, then 1 plus 1, the output will be 0, and the carry will be 1. Next clock pulse, 0 will be inserted here, then I have 0, 1, 1, 0. Okay? This one will have don't care, 1, 0. I don't care about if you want to input values, you can input, but I don't care about the contents. And I have 1 in the D latch. Next, I'll sorry, in the past, yes, 1. Okay, now this one, okay, with this 0 and this 0, I'll make it blue. Okay, this is 1 because D flip-flop will shift it. Then this 0, not this 0, this 0, and this 0 will be entered to the full adder. Then the result will be 1 and carry 0. The 1 will be shifted here again, then I'll get 1, 0, 1, 1. Okay, and here I'll be having don't care, 1. All right. Next, and finally, another clock pulse comes. Okay, the 0 will be moved here. Okay, the last inputs, the last inputs are 1 and 1. Okay, so 1 plus 1, 0, carry 1. Okay, then the 0 will come here, 0, 1, 0, 0, 1, 0, 1. Okay, here I'll be having don't care cases, it's all of them, but still I have 1 carry. Okay, maybe you said when I add 2 numbers the value should be more, but here it's less, 0, 1, 0, 1, but don't forget that I have a carry number here. Of course, this carry will go to the next stage and we'll continue the process. This is called serial adder, and if you studied already assembly language, when they were talking about the registers, register A and the accumulator A and register B, you will see that this is how things are happened inside the register. All right, that's it. I'll stop here, Johnson, and that's it. I don't want to put more pressure, but now we are going to take. I'll give you the lecture first. Okay. New conversation. No. Okay. All right, perfect. So this is the last lecture. Now from now on, we will start tutorial and practical sessions. So the first thing I want you to start, let's implement the flip-flops and start working on them. So this is the first thing. I will start. I think we've already developed or implemented the flip-flop. Let's try other flip-flops. Then we'll start from the beginning. By the way, this is just for now. And I have 1 second. I have D flip-flop and T flip-flop. Yes, no need to implement it. I can use it directly. So this is the T flip-flop. All right. enable and 0Q. This is the counter. All right. So let's try this. Also, I have here in the input output. There's a frequency. Okay, let's take the D flip-flop also, or let's implement first the shift register. So this is the D flip-flop. Let's take 4. Okay. Now the clock pulse. I'm just searching for the clock pulse. Where can I find it? I think it's in the input gate arithmetics wiring. Yeah, this is the clock. All right. It's better not to use the clock because we want to do it one by one. So I'll use regular input like this one, 0 and 1. And also, okay, I'll connect them now. So this is the clock pulse. No need to do this. Come on. Okay. This is the clock pulse. Now, first we will implement the serial one, and we'll see if what I told you is correct or what. So again, I need another one. This is the input, not this one. I'm sorry. This is the input. Okay. All right. So the output of every stage will be the input of the next stage. Okay, so this is what we got. This is another one. And here's the output. I'll put them down. Okay. This is the another output. I'll make it like this. All right, here is another output. Okay, and here's the last the first output. Okay, now I need output. Yes, LEDs. So I'll connect this to here. Okay, another LED. And another one. All right. Very well. But here, 1, 2, 3, 4. Now this is the input. Okay. As I told you in the clock bus, now suppose that I have here. I want to start. Yes. Now if I input 1, focus with me, please, and see how this one moves from one stage to another. But it depends on the clock. Okay. So the first clock, see, although the clock has entered in all stages, but only the first stage has become 1. Correct? Now, I'll change the input to be 0. Please keep a piece of paper with you and register what I'm doing now. Okay, next clock pulse. See, it didn't change. Why? Because the clock pulse has been changed from 1 to 0, but while the change will happen when I change from 0 to 1. So let's see this. The previous one has been shifted to be here, correct? And since the input is 0, the input became and entered the first stage. Now I can keep 0, then this 0 will move to this stage, this one will move to the next stage. But where? When I change the clock from 1 to 0, nothing will happen unless I change it from 0 to 1. So 1 to 0, nothing happened. Now see, This 0 shifted here, and this 0 shifted here, and the previous one shifted to be here. Now, if I want to enter 1, okay, again, this one has been shifted here, the previous 0 shifted here, and this 0 can become here, and the 1 became. So this is the shift register. What we explained earlier, that the data will enter like this. Now, if I want to show you the parallel, the difference between shift and parallel, then I'll copy. I can do it. I'm not sure. Yes, I can. Very good. How to move this? Yes, Control C, Control V. All right. So this is the second circuit that we are talking about, which is the parallel. But here, the input will not be like this. Okay, the inputs will. I will be having several inputs. First I'll remove this. Okay. And this one also. I'll show you the difference. The clock pulse was not changed, okay? But only what will be changed here is the. I want to remove this. I'm just doing some housekeeping. Okay. All right. So also this one, I'll remove all the connections to make things easier. Okay. So the input will be here. I'll move the output. 1 second. DQ. All right. You know, I'll delete this and start over again. All right, so the input here, I want another input here. The input will enter to D. Okay, another input here. And another input here. All right, the output will be, this is the first output. This is the second output. This is the third. And this is the fourth. Okay, it's easy. I can connect them like this. T. All right. Perfect. See the difference? Now here I have only one input. Here I have 4 inputs. Okay, and the clock pulse is the same. Every clock pulse, all the inputs will go to the output. Now the first clock pulse, I want to start them. What happened? Nothing. Why? Because all of them are zeros. Now if I change this to be 1 and this also to be 1. See, although it has been changed to be 1, but the output remains 0. It waits for the clock pulse. See? I think the connection here is not connected here. It should be 1. So I think the problem with the connection, so let me just connect it again. Yeah. All right, all right. You know the problem here? That I did not connect the clock. Yes. So here I have to connect the clock. That's why. All right. Let's go back. All right. So see, 0, the output is 0. 1, the output is 1. 1, the output is 1, and 0, the output is 0. Now, if I change the clock pulse again, it will remain. Now, what will happen if I remove the input? For example, here, I will put 1, 0, 1, 1, then, okay. Now, if I remove the input, for any reason I want to remove, I don't know how to remove it, it's not possible. Anyways, if I remove the input, it will continue to hold this information. Of course, I want you to implement this. I'll save it to you. I'll give it to you now. It's register, shift, parallel and shift register. I want you to draw the truth table to implement it. And then in the next lecture, I want you to implement the T flip-flop and the counters. We will implement them together. And please try to go through the lectures. And next lecture will continue. Let me just upload this, attach from the computer. All right, from the desktop. Okay, where is it? Let's register. Yes, this one. All right. Then please implement it and see how it works, and we will continue our discussion next lecture, inshallah. So you take care, and if you have any questions. Do you have any questions? Anything?